Hello there, and welcome to Science for Sleep, where curiosity drifts gently like a paper boat, and science takes the quietest route to your dreams. Tonight, we're descending into a world most of us will never see, a place where sunlight surrenders to darkness, where silence grows thick and creatures glide through pitch-black water like ghosts with gills. This isn't a horror story, though it could be. It's a lullaby for the ocean's deepest places, a soft exploration of the abyss, the deep sea. It's hard to imagine, isn't it, that just beneath the shimmering waves we know so well, the ones we splash in, sail on and skim with stones, lies an entire universe of mystery, cold, crushing and quiet. A world stranger than fiction, but beautifully, terrifyingly real. So let me ask, where are you listening from tonight? Are you tucked under blankets by a window, or maybe drifting off in a small apartment a few stories up from the city lights? And what time is it where you are? Because somewhere far below the surface of this spinning planet, time means nothing at all. There is only pressure, and dark, and life that doesn't need the sun. If this journey brings you calm, or even just keeps your thoughts company, it would mean so much if you like this video or subscribe to the channel. It helps our little raft of wonder float out to others who might need it too. Now, I do hope this won't keep you too interested. Sleep is the destination after all, but if it does, at least you'll have learned something strange and beautiful before you drift away. So settle in. Let your breath slow. Let your mind loosen its grip on the day. And let's begin. Because somewhere, far beneath the weight of waves, in a blackness older than bones, waits the story of the deep. Let's begin not with a fact, but a feeling. Imagine standing on a beach at night. The tide is out, the stars are mirrored in wet sand, and the wind is slow, unhurried. You look out toward the sea and feel something ancient staring back at you. That feeling, that mix of awe and unease, it's not just poetic, it's biological. Humans have always sensed something otherworldly about the ocean, especially the deep. There's no light down there, no landmarks, no clear sense of scale. And for a brain that evolved under the sun, this absence of reference points is unsettling. The abyss doesn't just challenge our perception, it dissolves it. In the deep sea, there is no up or down, no sound that travels cleanly, no horizon to lean on. It's a place where physics bends gently towards strangeness. If you or I were to sink into the abyssal zone, even before the cold or pressure claimed us, our minds would begin to fray from lack of input. No light, no sound, just the slow crush of water and the stretch of time. And yet, it draws us. There's something oddly familiar about it. Some part of us seems to recognize the deep as more than just a scary void. Maybe that's because, in a way, it's home. Every human embryo, after all, floats in salt water. Our blood has the same salinity as ancient seas, and long before we walked, or even crawled, we swam. That memory lingers, faint but persistent. It's why people stare at aquariums the way they do, why deep ocean documentaries feel meditative, why blue light feels calming. Some researchers believe this is tied to what's called the biophilia hypothesis, the idea that humans have an innate connection to natural environments. But perhaps it goes deeper still, because the ocean is not just nature, it's mystery made liquid. It hides, it protects, and it humbles. When you stand at the edge of the sea, you're not just looking at water, you're peering into an evolutionary mirror, a reminder that the unknown isn't just out there, but in us too. And this strangeness, this allure, creates a kind of tension in the mind, curiosity coiled with caution, a gentle internal contradiction. We want to look, but we don't want to fall in. We want to know, but we also want to stay safe on the shore. So what then do we find when we cross that invisible line? When we dive not in dreams but in steel and science, and begin to sink below the reach of light? We find pressure, we find dark, and we find life. a kind of life that doesn't care what we expect. To descend into the deep sea is to leave human logic behind. Down here, fish have lights on their heads, eyes the size of dinner plates, or no eyes at all. There are creatures who feed by creating vacuums with their faces, others who trap prey using their own tongues as bait. The rules of land life simply do not apply. Down here, nature isn't just surviving, it's improvising. And that improvisation sparks something in us. Wonder, yes, but also a strange sort of kinship. Because like us, these creatures have adapted to a world they didn't choose. They're not monsters, they're solutions, floating equations worked out over millions of years that solve for pressure, darkness, scarcity, and silence. And maybe that's why the deep sea feels psychological. It reflects us in abstract, our fears, our adaptations, our longing for light in the dark. Just as we seek meaning in dreams and stories, deep-sea creatures seek food, warmth, survival. And in their bizarre elegance, we glimpse our own. So the next time you see a blobfish, a gulper eel, or a transparent jelly pulsing through darkness, don't laugh, don't look away, look closer. You might just be seeing yourself, in another shape, in another world, still floating. And now, having felt what the deep does to the mind, let's explore what humans have thought about it through time, how we've imagined the abyss before we ever touched it. Because before there was sonar, there were stories. Before we had cameras that could dive for hours or robots to map the ocean floor, we had imagination. And that imagination was, understandably, terrified. Nearly every ancient culture that lived near the sea also feared what lay beneath it. The deep was seen as the domain of monsters, gods, spirits, and curses. The Babylonians told of Tiamat, a chaos dragon of salt water whose defeat gave shape to the world. The Greeks spoke of Charybdis, a sea creature who swallowed entire ships in whirlpools. The Norse had the kraken slumbering in the deep, ready to rise and shatter hulls with its arms. Even today those old ideas echo. In horror films, the ocean is never just wet. It's ancient, indifferent, patient, the perfect backdrop for fear. But it wasn't just mythology. Sailors, explorers, and early scientists tried to make sense of the abyss with what little they had. In the 19th century, many still believed the deep sea was lifeless, a barren void, too cold, too dark, too pressurized for anything to survive. It made sense in a way. After all, we couldn't see it, and what we couldn't see, we often assumed didn't exist. But then came a shift. In 1872, the HMS Challenger set sail on a groundbreaking expedition. It dragged nets, measured depths, and brought up creatures no one had ever seen. Not monsters exactly, but strange life, real life, with weird shapes and luminous bodies, creatures that had been hiding in the dark the whole time. This changed everything. The deep was not dead. It was alive, just quiet, just hidden. And slowly we began to rewrite our stories. Science, of course, replaced myth. But even scientific language still carries traces of that older awe. We talk of the abyssal plain, the midnight zone. We use metaphors of ghosts and lanterns and alien forms, because it still feels unearthly. Even now, with advanced submarines and sonar, we've explored only a fraction of the ocean floor. The deep sea remains the least understood ecosystem on the planet. More people have walked on the moon than have visited the Mariana Trench. And so we continue to blend science with story. We watch real footage of deep sea jellyfish undulating like translucent parachutes. And still, part of us whispers, that's not from here. But it is. It's from Earth. It's just a part we haven't reached yet. And maybe that's the most important reminder of all. The abyss isn't elsewhere. It's part of our own planet, our own biology, our own story. So when we speak of what's hidden in the abyss, we're not just talking about unfamiliar creatures or vast geological trenches. We're talking about the frontier of our own understanding, the edge of the known, and the invitation to cross it. And with that, we gently drift into the science of what the deep sea actually is. Not what it feels like, not what we feared, but what it is. Before sonar, before deep-diving submersibles, before carbon fibre hulls and titanium arms, the abyss was something we imagined. And when we imagine in the absence of information, we tell stories. In the beginning, the deep sea was less an ecosystem and more a myth. It was a place of punishment, a home for gods, and a mirror of human fear. Ancient cultures didn't just map coastlines. They mapped their anxieties onto the waters beyond them. The Mesopotamians believed in Tiamat, the primordial goddess of the salt sea. She was chaos itself, coiled in the deep, and from her dismembered body the world was formed. Her depths weren't empty. They were womb and tomb, creation and destruction. In Polynesian myths, the sea was a living ancestor. It gave birth to islands, trees, and even people. But it also demanded respect. Storms and swells were not weather. They were moods. Violating sacred fishing grounds could awaken anger from the abyss. Greek mythology, ever prolific, offered the ocean as both chariot and challenge. Poseidon, the god of the sea, ruled with a trident and temperament. Sailors feared his wrath, blamed him for earthquakes, and offered sacrifices to calm the waters. But even he had limits. Beneath his domain lurked other forces: Charybdis, the monstrous whirlpool; Scylla, with 6 snapping heads; and Oceanid spirits, both beautiful and fickle. And then there were the sea serpents. Almost every maritime culture has its own version. Scandinavia's Jörmungandr, the world serpent who encircles the earth. Japan's Umibozo, a shadowy giant who smashes ships. The Leviathan of Hebrew tradition, a coiled force of apocalypse. Even indigenous tribes of the Americas told stories of water panthers and underwater dragons. These weren't just stories to frighten children. They were ways to explain the unexplainable. A ship vanishes, a serpent took it, a storm sinks a fleet. The sea was angry. We lacked instruments, so we used metaphor. In medieval Europe, maps of the ocean included illustrations of fantastical beasts. Here be dragons, the cartographers warned, or sometimes more literally, hic sunt dracones. And while many of these monsters were fabrications, they often had roots in real encounters. A beached whale mistaken for an island, a giant squid glimpsed for a moment in a foggy swell, a whale carcass, bloated and unfamiliar, described in letters that outlived the facts. The line between myth and observation was not clear, and perhaps even now it still isn't. In Chinese mythology, dragons were not fiery or evil, but wise and wet. They lived in palaces beneath the sea and controlled the rain. They were respected, even loved. Offerings were made not to appease them, but to connect with them. In contrast, the Bible portrayed the sea as chaotic and dangerous. In Genesis, darkness covered the face of the deep before creation. The book of Job describes Leviathan as untamable. The ocean here is a challenge to divine order. It must be subdued. This duality, the sea as origin and obstacle, runs through many traditions. In Hinduism, the cosmic ocean churned by gods and demons yielded the nectar of immortality. But it also birthed poison. In Maori legend, the ocean is a bridge between worlds, but cross it carelessly and you may not return. So much of early human understanding of the ocean hinged on narrative. Story became survival. Fishermen shared tales of sea spirits not just to entertain, but to mark hidden reefs, dangerous currents, and seasonal changes. Myth was a mnemonic. Even today, we feel that echo. We don't say shark encountered. We say shark attack. We don't call it an ecosystem collapse. We call it the ocean in crisis. We still cast the sea in storylines, as if it has motives, moods, and memories. And perhaps it does. Just not in a way we yet understand. There is also ritual. In many island cultures, rituals of ocean respect persist. In Hawaii, Traditional fishermen chant before casting nets. In the Philippines, some communities offer food to the sea before storms. In parts of the Arctic, Inuit hunters whisper apologies to seals, acknowledging the shared cycle of life and death. These aren't superstitions, they're philosophies. They recognize that the ocean is not a thing but a relationship, and the deeper we go, the more intimate that relationship becomes. Because to enter the abyss is not to conquer it, it's to be changed by it. As technology crept forward and the myths lost their edges, we didn't abandon the stories, we adapted them. Jules Verne imagined a submarine so advanced it could glide through the deepest trenches. H.P. Lovecraft conjured horrors from the sea floor that could fracture the mind. Even science fiction, for all its spaceships and stars, returns again and again to the ocean as metaphor. It is our alien world, right here, wet, waiting, and very real. And maybe that's the true power of cultural interpretations. They don't explain the sea, they reveal us, our hopes, our terrors, our desperate need to name what we cannot reach. And now, after the myths and metaphors, let us surface briefly and then plunge into the real. Because science, when done with wonder, is a story too, and the story of how we began to know the deep sea is every bit as strange as the legends that came before it. Science began with ships, with ropes and lead weights, with sailors leaning over rails, lowering tools into darkness and pulling them back up like fishing lines into myth. For a long time, this was all we had: plumb lines, sounding leads, and guesswork. One of the first major scientific efforts to truly investigate the deep was the HMS Challenger expedition. Launched in 1872, it spent 4 years at sea, circling the globe. The ship carried not soldiers, but scientists. Instead of cannons, it held microscopes. Instead of charting territory, it charted depth. The Challenger was the first vessel to conduct a comprehensive survey of the ocean floor. Its crew dredged the seafloor, sampled water temperatures, collected sediment, and recorded the presence of living creatures in parts of the ocean once assumed lifeless. It discovered over 4,000 new species, and it mapped what would become known as the Mariana Trench. This expedition changed everything. It transformed the sea from superstition to science, and yet it still felt like magic. Sailors on board wrote in journals with a kind of reverence, amazed by what they were hauling up in their nets. Glowing creatures, transparent ones, forms that looked like nothing on land. And still, we could only guess at what the deep truly looked like. Because even with samples, we were seeing life torn from context. By the time a creature reached the surface, it had suffered pressure changes, temperature shocks, and mechanical damage. It was like trying to understand a bird by looking at feathers scattered in the wind. That changed with cameras. In the mid-20th century, engineers began to develop pressure-resistant housings for cameras that could survive the crushing depths. William Beebe's bathysphere, in the 1930s, descended 3,000 feet and offered the first real glimpse of deep sea life in its habitat. He described fish with lights like headlights, shrimp that glowed blue, an ocean that was not empty but pulsing with slow, soft motion, and yet Beebe had no photos. His reports were written like poetry, vivid but unverifiable. Some scientists doubted his claims, some still do. But his writing lit the spark. Then came Jacques Cousteau. With his invention of the aqualung, underwater exploration entered a new era. Cousteau's films brought the ocean into homes around the world. While he didn't reach the abyssal zones himself, his work helped create a culture that valued ocean exploration. Submarines followed, ROVs, deep-diving vessels like Alvin, which in 1977 discovered hydrothermal vents along the Galapagos Rift. This was monumental, not just for the technology, but for what we found. These vents, spewing superheated water rich with minerals, were surrounded by ecosystems unlike any seen before. Giant tube worms, blind crabs, microbes that lived not on sunlight, but on chemicals. This was life, flourishing without the sun. It overturned a central assumption in biology, that all ecosystems ultimately rely on photosynthesis. These deep-sea communities ran on chemosynthesis instead. Life, it turned out, didn't need the sky. This discovery shifted how we think about habitability. If life can exist here, in the dark, under pressure, feeding on sulfur and metal, then why not under the ice of Europa? Why not on an exoplanet's ocean? The abyss became a model for alien worlds. And still, we'd only just begun to look. Today, less than 20% of the ocean floor has been mapped in detail. Not because we lack interest, but because the ocean is vast and the tools are expensive. Every expedition is a feat of coordination, funding and luck. We send down autonomous robots. We listen with sonar. We sift through thermal readings and chemical traces, and piece by piece, the picture sharpens, but mystery remains. For every discovery, a dozen new questions rise. What is that sound heard 3,000 meters below? What is this gelatinous shape drifting in the current, uncatalogued, unnamed? Why do some creatures congregate at depth for no known reason, forming patterns that seem almost intentional? We're not just mapping terrain, we're mapping behavior, interaction, ecology. And we're doing it with a strange combination of tools: satellites orbiting in space, lasers bouncing off waves, and nets dragged behind ships much like those used centuries ago. The old and the new, the mythical and the measurable. We name zones: mesopelagic, bathypelagic, abyssopelagic, hadal. Each name more theatrical than the last, but they help. They create mental maps. They let us imagine pressure not just as force, but as geography. They remind us that the ocean is not just one place. It is layers of mystery stacked like a dream. And perhaps that's where science meets story again, in the realization that knowledge does not eliminate wonder. It deepens it. To understand that the gulper eel exists, that it can unhinge its jaw and swallow prey larger than itself, is not to kill the magic, it's to refine it. To name the glow of a lanternfish not as sea magic, but as bioluminescence, a chemical process of luciferin and luciferase, is not to dull the shine, it's to know it more intimately. And still, we wonder, what else is down there? What haven't we seen? What languages are these animals speaking with flashes and pulses and migratory dances? We're no longer mapping myths, but we're not done telling stories. Only now the stories are written in data, in sonar shadows, in video clips of strange beings floating silently in the black. This too is a kind of myth-making, only this time we get to watch it happen in real time. Let's begin with something simple. What exactly is the deep sea? It's not just deep water. It's not simply where your feet can't touch the bottom or where the sun can't reach. It's a specific, measurable region of the ocean, defined not by imagination, but by light, pressure, and depth. The ocean, like the sky, has layers, zones, each stranger than the last. We start at the epipelagic zone, the surface to about 200 meters deep. This is where sunlight reaches. The sunlight zone. Most of what we know about marine life comes from here. Coral reefs, dolphins, tuna, plankton, sea turtles, all residents of this bright photic layer. But once you descend past 200 meters, light begins to fade. Welcome to the mesopelagic zone, or the twilight zone, stretching from 200 to 1,000 meters. Here, sunlight fades to shadow. Photosynthesis is no longer possible. Temperature drops, pressure rises. Then, at 1,000 meters, we fall into complete darkness. This is where the deep sea truly begins. The bathypelagic zone, or midnight zone, ranges from 1,000 to 4,000 meters. No sunlight at all. The only light here is bioluminescence, chemical light created by organisms themselves. Below that, from 4,000 to 6,000 meters, lies the abyssopelagic zone. Flat plains, pitch dark, cold as ice, and under immense pressure. The seafloor here is a desert of sediment and strange life. And finally, the Hadal zone, any place deeper than 6,000 meters. Named after Hades, the Greek god of the underworld, it includes deep trenches and crevices. It is the most extreme environment on Earth. This is the structure. These are the floors of the invisible cathedral beneath the waves. Pressure in the Hadal zone can exceed 1,100 atmospheres. That's over 16,000 pounds per square inch. Temperature hovers just above freezing, and yet there is life. But before we marvel at what lives there, we need to understand how it lives there. Because nothing about this environment is easy. Every adaptation is a response to stress, to scarcity, to dark. Let's start with pressure. For us, the pressure at sea level is 1 atmosphere. For every 10 meters you descend, you add another atmosphere. So at 1,000 meters, it's 100 atmospheres. At the bottom of the Mariana Trench, nearly 100. For most land creatures, including us, this would be instantly fatal. But deep-sea organisms aren't just tough. They're engineered by evolution in exquisite ways. Many have no rigid structures that can collapse. Their bodies are soft, gelatinous, flexible. This isn't weakness, it's strategy. Bones snap, fluid bends. At the cellular level, membranes are different. The fatty acids in deep-sea creatures' cell walls are adapted to remain fluid and functional under pressure. Enzymes and proteins are specially tuned to resist denaturing. Their internal chemistry is like a whisper adapted to shouting. Even DNA replications, the basic machinery of life, must be pressure-resistant. Scientists studying these adaptations are only beginning to understand the molecular alchemy required. Now, let's talk about light, or the lack of it. In the midnight zone, it is not just dim, it is black. The kind of black that has never seen dawn. Yet, paradoxically, this zone is full of light, just not sunlight. Roughly 90% of deep-sea animals are bioluminescent. They produce light through chemical reactions, often using molecules like luciferin, catalyzed by enzymes like luciferase. The result? Cold light, glowing bellies, blinking lures, flashing warnings. But why glow in a place with no sun? For many reasons. To attract mates, to lure prey, to camouflage from predators. Some fish use counter-illumination, glowing bellies that match the faint light from above, making them invisible when viewed from below. Some flashes are used to stun predators, to communicate, to distract. In a world of total darkness, a single flash is a language. Then there are the creatures with light-producing bacteria living inside them. Symbiosis in the dark. Entire relationships built on glow. And the forms, they're as varied as they are strange. Take the anglerfish, with its bioluminescent lure, or the vampire squid, which isn't a vampire or squid but has blue cloak arms and glowing arm tips. There are glass octopuses nearly invisible, giant amphipods that look like armoured shrimp, and jellyfish that bloom like galaxies. Most have adaptations for a life of drift and weight. They are not runners, they are floaters, lurkers, minimalists. Food is scarce. Energy must be conserved. Which brings us to the next essential concept. Energy and food webs. Where does energy come from in the deep sea? If there is no sunlight, what feeds these creatures? There are 3 major sources. First, marine snow. A constant fall of organic matter from the upper layers of the ocean. Dead plankton, fecal pellets, bits of carcass. It drifts down like slow, soft snowfall, feeding bottom dwellers. Second, carcasses. Occasionally a large animal, a whale, a shark, a sea turtle, dies and sinks. This is a banquet. A single whale fall can feed an entire ecosystem for decades. First come the scavengers, then the hagfish, then bacteria and bone-eating worms, and third, hydrothermal vents and cold seeps. Here, life thrives not on light, but on chemicals. Chemosynthesis. Bacteria convert hydrogen sulfide or methane into usable energy. These bacteria form the base of a food web supporting clams, crabs, tube worms, and these food webs, they're ancient, possibly more ancient than photosynthesis-based systems. In the deep sea, life is not a race. It is a negotiation. Every adaptation is a whisper to the dark. Let me stay. And somehow, life persists, in forms that shimmer, in forms that wait, in forms that no one has yet seen. And now, having set the structure, the light, the energy, and the pressure, we're ready to descend further. Because the deep sea isn't just a place, it's a world with its own physics, its own logic, its own rules of survival. In the next section, we'll meet the residents of the deep more intimately. Not just what they are, but how they live and how they challenge what we thought life could be. Let's meet the residents. Start with the anglerfish, perhaps the most iconic face of the deep. A wide mouth, needle teeth, and a glowing lure dangling from its forehead like a lamp on a nightstand. But the most curious thing about it isn't the lure, it's the male. Male anglerfish are tiny. Some are 1/10 the size of females, and when they find a mate, they attach themselves permanently to her body. They bite her side, fuse their tissues, and eventually lose their eyes, fins, and even organs. They become part of her. A parasitic sperm donor living in fusion. Not exactly a romantic comedy, but a brilliant evolutionary tactic for a world where encounters are rare. Or consider the gulper eel. Its mouth is so large it can consume prey much larger than itself. It doesn't chase. It simply opens wide and waits. The jaw unhinges, the skin stretches, and in goes whatever happens to be passing by. The vampire squid, despite its name, drinks no blood. It drifts gently, arms webbed like a cloak. Its strategy? Conservation. It has the lowest metabolic rate of any cephalopod. In a world with little food, it survives by barely moving. There are barrel-eye fish with transparent heads and upward-facing eyes, encased in a dome of clear tissue. They can rotate their eyes within the dome, watching both above and forward, like a submarine periscope evolved into flesh. Or the glass octopus, nearly invisible, internal organs floating inside a translucent body. No ink, no pigment, just silence and vulnerability turned into stealth. There are tripod fish who rest on the seafloor with elongated fins like stilts. They perch, motionless, sensing vibrations in the water, waiting, always waiting. And then there are creatures we haven't even classified yet, shapes caught by ROVs that don't match anything in our taxonomies, pulsing, curling, hovering, strange loops of transparent tissue, lights flickering in the internal spirals. Some have names like dreams, the cosmic jelly, the feather star, the comb jelly, the ghost shark. Some glow blue, others red. Red light, interestingly, is invisible at these depths, which means creatures that are red appear black and nearly invisible. This is adaptation not just for survival, but for strategy. Camouflage in a colour that no one can see. Then there are the behaviours. Many deep-sea animals perform a vertical migration each night. From hundreds of metres below, they rise toward the surface under cover of darkness to feed, then return to the depths before sunrise. It's called diel vertical migration, and it's the largest movement of biomass on Earth, and it happens in silence, every night, while we sleep. The scale of deep sea life is also vast. From the giant squid, once thought mythical, now confirmed, to microscopic extremophils living in the pores of rocks. Some creatures are long-lived, others barely have time to grow, and yet nearly all of them remain hidden. Why? Because light is limited. Human access is limited. Even with the best submersibles, we can only stay so long. We can only cover so much ground. And the creatures there, they often avoid us. Sound startles them. Light blinds them. Machines don't blend in. We are in many ways clumsy visitors. Even when we do see them, much is lost in translation. A jelly filmed by an ROV may pulse differently under stress. A fish may flee instead of hunt. These snapshots are just that. Fragments, but they add up. and each new encounter stretches our definition of what life is. Take the Hadal snailfish, found in the Mariana Trench, deeper than any other known fish. It has no swim bladder. Its bones are soft, its flesh almost gelatin. It lives in an environment with more pressure than the surface of Venus, and yet it eats, it grows, it reproduces. Or the Osidax worms, also called bone-eating worms. They have no mouths, no stomachs. The females anchor themselves to bones, such as whale falls, and digest them using symbiotic bacteria. Males? They live inside the females, hundreds at a time. Their sole function is reproduction. We are far from the savannah now. Even viruses are different here. Some scientists believe the deep ocean harbours unique viral ecosystems, infecting bacteria and archaea in cycles we don't yet understand. These micro-interactions could shape nutrient flows, evolution, even climate. Every level of life, from the molecular to the monstrous, behaves differently in the deep. And perhaps the most astonishing thing, these creatures are not fragile, they are ancient, resilient. Many species have remained unchanged for millions of years. Some even survived mass extinctions that wiped out most surface life. Down here, change is slow, but survival, unyielding. That is the lesson of the deep, that life does not need light to thrive. It needs time, space, and silence. In the next part, we'll explore the anomalies and edges of this world. Creatures that bend biology, vents that breathe minerals, and ecosystems that challenge our idea of what a biosphere even is. Because the deeper we go, the stranger life becomes. Let's step past the familiar strange and enter the truly alien. Because the deep sea isn't just home to weird creatures. It contains entire systems of life that defy what we thought was possible. Start with hydrothermal vents. Imagine a crack in the seafloor, thousands of meters down. From it, scalding water erupts, not boiling but heated to hundreds of degrees Celsius by magma beneath the crust. The pressure keeps it from vaporizing. This water is dark, acidic, and full of dissolved minerals, hydrogen, sulfide, iron, methane, and yet around these vents life blooms, giant tube worms with blood-red plumes, vent crabs white and blind, Riftia pachyptila, which can grow taller than a man. These organisms don't eat in the way we understand. They rely on chemosynthetic bacteria that live inside them or coat nearby rocks. These bacteria take the toxic chemicals and turn them into energy. They are the base of the food web. They are lightless photosynthesizers, a different origin story for life. Discovered only in 1977, these ecosystems shocked the scientific world. They suggested that life didn't need the sun, that perhaps even on Earth biology had more than one blueprint. And then came cold seeps. These are areas where hydrocarbons, methane, ethane, oil, seep from cracks in the ocean floor. No heat, but still life. Clams with chemosynthetic bacteria in their gills, mussels with methane-loving symbionts, shrimp clustering around chemical flows. Bacteria form mats like fields of filament carpeting the seabed. Both vents and seeps host organisms that live in partnership with bacteria. They don't graze, they house, they cultivate. The relationship is so close, it's hard to say where one life ends and the other begins. Even stranger. These ecosystems are temporary, vents cool, seeps shut, but the communities adapt. Larvae drift until they find a new vent. Generations cycle in waves of heat and mineral and dark. Entire biomes blooming in geothermal breath. Now let's talk about brine pools. Yes, underwater lakes inside the ocean. These are pockets of water so salty they don't mix with the surrounding sea. They sit in depressions on the seafloor, denser, still, with visible shorelines and waves. Crossing into a brine pool is like crossing dimensions. It can be fatal for most marine life, but some organisms thrive there. Bacteria adapted to hypersaline conditions, mussels clinging to the shores. It's the closest thing we have on Earth to discovering an alien sea. There are also methane hydrates. crystalline cages of ice and gas that form under pressure. Some theorize these deposits could store massive amounts of energy. Others worry they could release greenhouse gases if destabilized. In these landscapes, biology meets geology. The line between organism and environment blurs. Life builds from rock, from chemical, from contradiction. And then there are the zombie worms, Osedax, discovered feeding on whale bones, lack mouths, stomachs, and even traditional digestive systems. They secrete acid to bore into bone, then digest with the help of symbionts. They have root-like structures that grow into the marrow. They are decomposers in a place with no topsoil, gardeners of the forgotten. Some worms reproduce by broadcasting eggs and sperm. Others keep harems of microscopic males. Some reproduce once and die. Others clone themselves. Time works differently here. Growth is slow, change is rare, but persistence, that is eternal. We also find extremophils, bacteria and archaea that live in temperatures above boiling, in acid, in pure metal brine. They change what we thought life could tolerate. They expand the concept of habitable zone, which brings us to one of the most astonishing implications of deep-sea research, the possibility of extraterrestrial life. Europa, one of Jupiter's moons, is covered in ice. But beneath that ice, a subsurface ocean, possibly warmed by tidal forces. If Earth's hydrothermal vent systems can host entire ecosystems without sunlight, then why not Europa? Enceladus, a moon of Saturn, shoots plumes of water vapor into space. Some contain organic molecules. Could there be vents there too? Even exoplanets, planets orbiting distant stars, may have oceans beneath ice shells or within atmospheric layers. Our definition of Earth-like is shifting. Maybe it means watery, maybe it means deep. Studying the abyss isn't just marine biology, it's astrobiology. It's learning how life might look when built from different rules. And perhaps most humbling, we still haven't found the bottom of it. New trenches, new species, new chemistry. Every dive is a chapter in a book we didn't know we were writing, and all of it, the glowing fish, the worm forests, the methane lakes, exists not in a fantasy world, but in the same oceans we swim in, the same waters we splash in at the shore. The abyss is not elsewhere, it's here, just hidden. So we continue to explore, not just with machines, but with questions. How does light shape behavior when it's only ever artificial? How do organisms mate when they may never meet? What does community mean in a world of drift? And when we look outward to alien seas, it will be these creatures, the worms, the jellies, the invisible shrimp, that guide our search. Because they are the proof that life is not fragile. It is adaptive. And most of all, it is strange. Stranger than fiction. Stranger than fear, stranger than we dared believe, and yet utterly real. To understand how we came to know the deep sea is to tell a story of glimpses, of slow reveals, of tools invented not just to measure, but to believe. Because for most of human history, the deep ocean wasn't just inaccessible, it was unimaginable. Let's begin with sounding lines. Simple tools. Weighted ropes lowered from ships to estimate depth. Crude, but effective. They told us the ocean had contours, valleys, slopes, that it wasn't just flat and endless beneath the surface. One of the earliest documented deep-sea soundings was in 1521, when Magellan's crew dropped a line in the Pacific and found no bottom at 730 fathoms. The line just kept going. The ocean swallowed it. Later, in the 19th century, lines grew longer, techniques improved. The British ship HMS Challenger, in the 1870s, conducted over 500 soundings. It reached depths of over 8,000 metres in the Mariana Trench, a discovery that stunned the world. But even then, we were still measuring absence. A rope tells you something is down there, but not what. To see required invention. Enter the bathysphere. In 1930, naturalist William Beebe and engineer Otis Barton built a steel sphere with tiny windows and a breathing system. Suspended by cable, they descended off the coast of Bermuda. No camera, no lights beyond their own, just eyes, pressed to a portal staring into black. They reached 3,000 feet, and what they saw changed everything. Fish with lights, jellyfish with internal flames, shrimp that glowed like coals. Beebe described a fish with the face of a pig and the body of a balloon, a luminous eye the size of a coin. Skeptics doubted him. No photos, no proof. But Beebe's poetic logs hinted at a truth science wasn't yet ready for. The deep was not barren. It was filled with light. In the decades that followed, technology caught up. Cameras built into pressure housings, lights that could survive the crush, remote-operated vehicles, and then came Alvin. Commissioned by the US Navy in 1964, Alvin was a small, manned submersible, capable of reaching deep-sea floors. It was aboard Alvin that scientists discovered hydrothermal vents in 1977, and the ecosystems that surrounded them. Suddenly the deep wasn't just deep, it was vital. Alvin also helped recover a lost hydrogen bomb, explored the Titanic, and became a symbol of how far human curiosity could reach. But it wasn't just government projects. In 1960, Swiss scientist Jacques Picard and US Navy Lieutenant Don Walsh boarded the Trieste, a bathyscaphe with a thick glass viewing window and a body built like a floating tank. They descended to the bottom of the Mariana Trench, nearly 11,000 meters down. No one had ever been there, and for over 50 years no one went again. They reported seeing a flatfish, though later analysis suggested it was likely a sea cucumber or another benthic organism. Still, they proved it was possible, that humans could touch the planet's deepest point. Since then, others have followed. Robotic dives, autonomous vehicles, even filmmaker James Cameron in 2012, who soloed the trench in a custom-built sub called Deep Sea Challenger. These milestones mark progress not in distance, but in presence. Each one a candle lit in the dark, and yet, for all this machinery, we still struggle with the same basic question. What's down there? Because the ocean, unlike space, is resistant to clarity. Water obscures, pressure crushes, darkness absorbs. Even today, mapping the ocean floor is like blindfolded cartography. We use sonar, bouncing sound waves off the bottom, translating echoes into shape. It works, slowly. The most detailed maps of the seafloor come not from direct observation, but from satellites measuring tiny changes in sea surface height. These changes, caused by gravity and underwater topography, hint at mountains, trenches and ridges. It's like reading Braille from orbit. And still, only about 20% of the ocean floor has been mapped with high resolution. There are mountain ranges bigger than the Andes we haven't named, trenches deeper than Everest is tall that remain anonymous, and for the parts we have seen, we're still interpreting. ROVs and AUVs, remotely operated and autonomous underwater vehicles, now do much of the deep work. They can dive for days, explore where it's too dangerous for humans, and collect samples with robotic arms. One of the most ambitious efforts is Seabed 2030, a global initiative to map the entire ocean floor by the end of the decade. It relies on open data, international cooperation, and ships equipped with multi-beam sonar. But it's a massive task. The ocean covers over 70% of Earth's surface, and much of it is just far, remote, rough, expensive. Still, we persist. Not because it's easy, but because something calls us. Maybe it's the fact that so much of our own world is still hidden, that for all our satellites and sensors, we remain land creatures dreaming of depth. Or maybe it's older than that. Maybe it's the ancestral pull, the whisper in our bones, the part of us that remembers water before breath. Because when we explore the deep, we aren't just learning about the ocean, we're learning about ourselves. In the next part, we'll look at the thinkers, tinkerers, and visionaries who helped shape our understanding. not just through machines, but through imagination, through metaphor, through the long, slow wonder of asking, what lies below? There is a thread that runs through every great leap in deep sea discovery, and that thread is human imagination. Long before we had submersibles, we had sketches, paintings, stories, and hypotheses. The sea wasn't empty because we didn't understand it. It was full, overflowing with whatever ideas we projected into its dark corners. Science grew not in the absence of myth, but from it. Consider Jules Verne. In 1870, Verne published 20,000 Leagues Under the Sea. A novel, yes, but more than that, a blueprint. In it, Captain Nemo pilots the Nautilus through coral forests, sunken ships, and undersea volcanoes. Verne imagined electric propulsion, pressure-resistant hulls, even scuba gear long before they existed. His fiction inspired generations of explorers and engineers. Even Jacques Cousteau cited Verne as a childhood hero. Or think of William Beebe, not just a naturalist, but a storyteller. His bathysphere dives in the 1930s were scientific, but his descriptions read like dreams. He saw not just fish, but flickering spirits of the deep, light as emotion, movement as mystery. Beebe didn't invent fantasy, he translated it. Then came the pioneers of technology, Jacques Picard, who built Trieste with his father, Auguste. Their work on buoyancy and pressure-resistant design laid the foundation for modern submersibles. The bathyscaphe they built didn't look sleek, it looked absurd, but it worked. It went deeper than anyone thought possible. James Cameron followed in their footsteps but added cinematic flair. His deep-sea Challenger was designed not just for depth, but for film. The mission was both exploration and storytelling. And let's not forget Sylvia Earle. An oceanographer, explorer, and tireless advocate for marine conservation, Earle has spent thousands of hours underwater. Her early dives in submersibles during the 1960s and 70s helped gather key data about oceanic zones. But more importantly, she spoke about the ocean as something intimate, personal. She once said, "You should be down there with a camera in your hands and tears in your eyes, because science, without emotion, rarely gets remembered. The tools of exploration have evolved. Sonar, GPS, remotely operated vehicles. But behind every tool is a person, a thinker, a poet in disguise. Even the mathematical models that help us estimate undersea terrain require a kind of narrative logic. Algorithms predict shapes based on echoes. They imagine what the seabed looks like, then verify it through pattern. In that sense, even our most advanced mapping systems are storytellers. They create probable worlds out of pulses. It's easy to forget that, to reduce oceanography to charts and data points. But there are people, living, breathing, dreaming people, behind every sonar ping. And as we dig into the past century of exploration, a curious pattern emerges. Every generation believes it has seen the limits of life, and every generation is proven wrong. In the 1800s, scientists believed no life could exist below 600 meters. Then came deep trawls. In the early 1900s, it was believed nothing could survive without sunlight. Then came hydrothermal vents. In the mid-20th century, pressure was thought to be the ultimate barrier. Then came Hadal fish. Each time, the abyss quietly raised an eyebrow and showed us something new. There is humility in that. A reminder that our knowledge is provisional, that Earth still holds secrets. Even the act of naming species is a kind of poetry. Consider the names. Thermaces cerberus, a fish named after the guardian of the underworld. Halocephalobus mephisto, a worm named after a demon found a mile underground. Bathyphysa conifera, a siphonophore dubbed the flying spaghetti monster for its tangled elegance. Science names with Latin precision, but also with awe. And awe matters. It fuels funding. It fills classrooms. It turns quiet facts into loud questions. And those questions push us deeper, like, could extremophile microbes help us develop better antibiotics? Could deep-sea enzymes withstand industrial processes? Could materials from deep-sea sponges help fight cancer? These aren't hypotheticals, they're active areas of research. Bioprospecting in the deep sea is a growing field. It walks a delicate ethical line, but it's already yielding insights, new compounds, resilient proteins, novel genetic material. The abyss is a library. Only now are we learning to read it. And the more we read, the more we realise we've only seen the prologue. In the final part of this historical arc, we'll look at the future. How artificial intelligence, citizen science, and a new era of ecological awareness are changing the way we explore and protect the deep. So where are we now? In an era where technology whispers through fibre optic cables and machines dream in code, our exploration of the deep sea is undergoing another transformation, one driven not just by engineers or institutions, but by algorithms, communities, and quiet urgency. Let's start with artificial intelligence. Deep-sea exploration now involves massive data collection. Sonar maps, video footage, environmental DNA, acoustic signals. Too much for any single team to analyse alone. So we teach machines to help. AI sorts patterns. It identifies species. It flags anomalies in footage. It learns to recognise the flicker of a jellyfish, the curve of a squid, the slow crawl of an isopod across sediment. What once took months of manual review can now happen in hours. But these systems do more than accelerate science. They open doors. Because the next frontier in exploration isn't just physical, it's democratic. Organisations like Ocean Observatories Initiative and Ocean Networks Canada publish live feeds from the deep. ROV dives are streamed online. Schools can watch. Citizens can contribute. Volunteers around the world annotate video logs, helping scientists sift signal from noise. This is citizen science, and it's changing who gets to explore. You don't need a degree or a vessel, just curiosity. Projects like FathomNet create open-source datasets for training AI models on marine imagery. Others use environmental DNA, fragments of genetic material left in water, to detect species without ever seeing them. Like reading footprints in sand but with molecules. And it isn't just about discovery, it's about protection. Because in recent decades, the deep sea has come under threat. Deep-sea mining has emerged as an industry in waiting. Vast fields of polymetallic nodules, rich in cobalt, nickel, manganese, lie scattered across the abyssal plain. The demand for rare earth elements, driven by batteries and electronics, makes these deposits tempting. But harvesting them means disrupting ecosystems that took millennia to form. Sediment plumes could smother habitats. Noise could disorient species. The consequences are largely unknown, and unknowns, in science, are warnings. In response, scientists and environmental groups are calling for caution. Some advocate a moratorium on deep-sea mining until we understand the risks. Others push for marine protected areas, even in the Hadal zones. We've begun to realise that knowing the deep sea is not enough. We must also choose to keep it. This ethic of guardianship has grown alongside our technical ability. The more we see, the less we want to harm. The more we understand, the more fragile it feels. It's a reversal. Once, the abyss was feared because it was unknown. Now, it's revered because it is unknowable. Even as sensors proliferate, mysteries multiply. Species appear once and never again. Sounds echo through trenches, origin unclear. Chemical traces hint at life forms we haven't yet met. And so we proceed. Not as conquerors, but as witnesses. The future of deep-sea exploration lies in cooperation. International efforts like the UN Decade of Ocean Science for Sustainable Development aim to unify data, share knowledge, and align discovery with stewardship. Technologies are advancing, yes, but so is our humility. We no longer look down into the deep as if it were a canvas for exploitation. We look up at it as if it were a sky inverted, mysterious, beautiful, worth preserving. And that shift, that widening of perspective, may be the greatest discovery of all. Because it doesn't come from sonar or AI, it comes from us. from remembering that we are not separate from the ocean, we are part of it. Every breath we take owes a debt to phytoplankton. Every climate model hinges on ocean currents. Every storm, every season, every sunset on a beach is touched by tides. To know the deep is to understand not a world apart, but a world within. And in that knowing, perhaps we remember something ancient, something quiet. The truth that for all our satellites and cities we are still small creatures on a blue planet floating in black. The ocean will continue, with or without us. But if we are kind, if we're curious, if we are willing to protect what we have only just begun to know, then perhaps the story of the abyss is not a tragedy. Perhaps it is a lullaby, a deep, slow song, still singing, still unfolding, still waiting to be heard. Before science, there were stories. The earliest human relationship with the sea was one of necessity and fear. We built boats to cross it, but rarely dared to dive into it. The deep was the place of monsters, of gods, of the unknown. Fishermen spoke of creatures too large to fight, too strange to name. Every coastline culture had a version: the sea serpent, the kraken, the leviathan. They weren't always real, but they were always meaningful. These stories were not just entertainment, they were explanations. Before bathymetry or biology, mythology offered structure to the formless black beneath the waves. But eventually, questions replaced fears. The idea that the ocean might be explored, mapped, understood, even measured, began to take hold in the Enlightenment. Though limited by technology, curiosity was constant. The first tentative steps toward real ocean science didn't come from biologists, but from sailors, merchants, and cable companies. In 1818, the British ship Isabella attempted to find a northwest passage and took one of the earliest deep-sea temperature readings. But it was crude. Buckets and ropes, a guess at best. Still, interest was growing. Then came Edward Forbes. In the 1840s, Forbes put forth the azoic hypothesis, the belief that marine life could not exist beyond 600 meters. It was tidy. It made sense to scientists of the time. After all, no sunlight penetrated those depths. The pressure was immense. Why would anything survive there? And yet, even as Forbes's idea spread, it was already unravelling. By the 1850s, engineers working on the transatlantic telegraph cable began pulling strange creatures up from greater depths. Not many, but enough to make scientists wonder. If life could exist a mile down, what else might be possible? Then came the HMS Challenger. Launched in 1872, the Challenger expedition was a turning point. It was the first voyage designed specifically for oceanographic science. Over nearly 4 years, the crew collected thousands of samples, conducted hundreds of soundings, and catalogued previously unknown species. It was slow, laborious, analogue work. Rope lines were lowered, often for hours, to measure depths. Thermometers were sent into the deep to record temperature. Nets were hauled up by hand, and yet the results were staggering. The expedition recorded over 4,700 new species. It mapped underwater mountain ranges. It measured what would later be named the Challenger Deep, the deepest known point on Earth. It proved definitively that life existed even in the cold, crushing dark. In one voyage, the ocean had gone from mystery to frontier. The Challenger's findings filled 50 volumes. It became the bedrock of modern marine science, and it laid to rest the azoic hypothesis for good. The early 20th century brought new instruments. Echo sounding, invented in the wake of the Titanic's sinking, changed everything. By bouncing sound off the seafloor and timing its return, scientists could map depth quickly and more accurately than with ropes. Suddenly the ocean had shape. We saw trenches, ridges, abyssal plains. The seafloor was not flat but wild, mountainous, fractured, dramatic. As this geologic structure became clearer, new questions emerged. Why do mid-ocean ridges exist? Why are ocean floors so young, geologically speaking? This led to one of the most profound shifts in Earth science, the theory of plate tectonics. Scientists like Marie Tharp, Bruce Heason and Harry Hess noticed patterns in seafloor spreading and magnetic striping. They realised that the ocean floor was not static, it was in motion. New crust was being created at ridges and destroyed at trenches. The ocean floor was not just shaped by the Earth, it shaped the Earth. This realisation turned oceanography into a planetary science. Meanwhile, biology continued to push boundaries. Early deep-sea trawling in the late 1800s and early 1900s brought up creatures no one expected. Animals with glowing organs, huge eyes, transparent skin. The term bioluminescence entered the lexicon, and the ocean took on a new aura. Not just dark, but full of light that science could not yet explain. In the 1930s, William Beebe and Otis Barton descended in the bathysphere off Bermuda, reaching depths of nearly 1,000 meters. They saw creatures no human had seen alive in their own habitat. Glowing jellies, deep-sea fish with lanterns for eyes. Their reports were met with skepticism. Some scientists dismissed their descriptions as exaggeration, but the die was cast. Humanity had pierced the veil. It wasn't until 1960 that we reached the deepest known point in the ocean, the Challenger Deep. The vessel was the Trieste, a bathyscaphe built by Swiss engineer Auguste Piccard and piloted by his son Jacques Piccard and US Navy Lasseurs Don Walsh. They descended nearly 11 kilometers into the Mariana Trench. The pressure was over 1,000 times atmospheric levels. The descent took nearly 5 hours. They stayed on the bottom for just 20 minutes, and they saw life. It looked like a flatfish. Though later reanalysis questioned that ID, still, it was movement. Proof that life could exist at the very edge of possibility. The descent of Trieste was a human triumph, but it was also a pause. For decades, no human would return to the deepest trench. Instead, we sent machines. Remotely operated vehicles, ROVs, and autonomous underwater vehicles, AUVs, took on the task. They could go deeper, stay longer, and take risks humans couldn't. Equipped with cameras, arms, sensors, they became our surrogates in the dark. In 1977, using Alvin, a US research submersible, scientists discovered something unexpected: hydrothermal vents near the Galapagos Rift. From these vents spewed scalding, mineral-rich water. Around them, ecosystems teeming with life. Tube worms taller than humans, blind shrimp, bacteria that fed not on light, but on chemicals. It was a revolution. Until then, we believed all ecosystems depended on the sun. But these communities didn't. They were powered by chemosynthesis, life from chemistry, not light. This upended everything. If life could exist there, what about other planets? Moons like Europa or Enceladus, with icy crusts and possible subsurface oceans. The deep sea wasn't just an earthly mystery anymore, it became a cosmic possibility. And so we kept going. We mapped more of the seafloor using sonar and satellite altimetry. We developed better submersibles. We used deep diving robots to film ghost sharks, giant squid, and bizarre gelatinous creatures that looked more like ideas than animals. Each step built on the last, but each step also deepened the mystery, because the more we saw, the more we realized how little we understood. By the early 21st century, the ocean had become not just a place of exploration, but a system, one interwoven with climate, biodiversity, and global stability. And the deep sea, no longer just mysterious, but essential. Let's begin with data. Over the last 2 decades, marine science has entered a new phase, not exploration by intuition, but exploration by information. Satellites measure sea surface temperature, sea level, and gravitational anomalies. Drifting Argo floats roam the upper 2,000 meters of the ocean, collecting salinity and temperature profiles, transmitting them in real time. But the deep sea still resists easy monitoring. It's not just vast, It's hard to access, expensive, and in some places actively hostile. That's where autonomous systems step in. Modern AUVs, autonomous underwater vehicles like Boaty McBoatface, Nereus and Orpheus, roam the depths untethered, mapping ridges, photographing thermal vents, and sniffing for chemical signatures. Some are designed to mimic marine life, torpedo-shaped, neutrally buoyant, nearly silent. Remotely operated vehicles like ROV Jason and ROV Sebastian have streamed breathtaking footage from thousands of meters below, revealing ecosystems living on whale falls, coral gardens blooming in darkness, and fish with antifreeze in their blood. These machines don't just extend our reach, they multiply it, and their discoveries keep rewriting our assumptions. We've learned that the abyssal plains, once thought barren, are biologically active, that species we assumed were rare are sometimes widespread, that deep sea corals can be thousands of years old, that sponge fields may act as carbon sinks, that creatures in the Hadal zone, below 6,000 meters, are more diverse than previously imagined. We've also started listening. Acoustic monitoring networks now track everything from whale migrations to underwater earthquakes. Mysterious low-frequency sounds like the bloop detected in 1997 have sparked both scientific and public fascination. While most such sounds are eventually explained, in that case likely an icequake, the fact remains the ocean is noisy and not all of it comes from us. But increasingly more of it does. Human activity now echoes in every trench. Microplastics have been found in the Mariana Trench. Mercury accumulates in deep-sea fish. Industrial fishing gear litters slopes thousands of meters below the surface. And perhaps most controversial of all, the threat of deep-sea mining. As demand for metals like cobalt, nickel, and rare earth elements grows, companies and nations have turned their attention to the seafloor. In particular, they seek polymetallic nodules, potato-sized lumps that form over millions of years and sit scattered across the abyssal plains, especially in the Clarion-Clipperton zone between Hawaii and Mexico. To harvest them means scraping vast areas of sediment, disturbing or destroying habitats we barely understand. The technology exists, the laws do not. The International Seabed Authority, which governs mining beyond national jurisdictions, has yet to finalise environmental protections or long-term regulations. And while exploratory licenses have been granted, a growing chorus of scientists and environmentalists is calling for a moratorium, because we've seen this before, discovery followed by exploitation. But the deep sea offers a chance to do things differently. The deep ocean is now seen as a global commons, a realm beyond borders, owned by none, shared by all. Its protection is no longer just a scientific issue, but a political, ethical, and philosophical one. And science is evolving to meet that responsibility. Collaborative projects like Seabed 2030 aim to map the entire ocean floor by the end of this decade, a goal that would have seemed impossible just 10 years ago. The rise of open science means that footage from ROV dives, sonar data, and even genetic sequences are increasingly being made public. Citizen scientists can now help identify species from live streams, tag imagery, and support annotation efforts. We're also developing new analytical tools. With the advent of environmental DNA, eDNA, researchers can detect organisms by filtering seawater and extracting genetic fragments. This allows for surveys that are faster, less invasive, and more comprehensive than traditional trawling. Entire ecosystems, including some that were unknown just a decade ago, are now being revealed by molecules alone. At the same time, machine learning and AI are transforming how we interpret data. Algorithms can now recognize species in video, identify new patterns in seafloor terrain, and even predict where undiscovered life might be hiding based on environmental variables. And still, the deep resists final understanding. Some creatures remain uncategorized. Some habitats exist for mere decades, then vanish, like ephemeral vent fields or whale falls. New trenches are still being mapped. Anomalies persist in temperature readings, chemical samples, sonar returns. We are, in every sense, still at the beginning. The modern view of the deep sea has come full circle, from fear to reverence, from ignorance to awe. Once the abyss was a place of monsters, then it became a place of machines. Now it is a place of meaning. And the more we explore it, the more it reflects us back to ourselves. Our capacity for wonder, our hunger for knowledge, our power to harm, our hope to heal. The story of how we've come to understand the deep sea is not just about instruments or expeditions, it's a story of transformation, in perception, in ethics, in ambition. From myth to measurement, from conquest to care. And now, as we stand on the edge of greater technological power than ever before, the question is no longer just what can we learn, it's what kind of explorers will we be? What is it exactly that draws us toward the abyss? It is not warm, it is not welcoming, it is not built for us. We are soft-skinned, gasping creatures, made for air and light, and yet the thought of the deep ocean pulls at us, the way dreams do, quietly, persistently, a presence behind the curtain. There is something deeply human about staring into the dark and wondering, what is down there? Not just what lives there, but what is that place? And why does it feel like it knows us? The abyss, after all, is not simply physical, it's symbolic. It stands for everything outside our comfort, outside our perception, beyond our reach. It is not just a trench, it is an idea. And ideas have gravity. Philosophers have long seen the ocean, especially the deep, as a metaphor for the unknown, the unconscious, the eternal. Nietzsche warned of staring into the abyss. Freud spoke of mental landscapes as if they were oceans. Jung referred to the unconscious as a dark, watery depth. We speak of depth to mean seriousness, unknowability, soul. To go deep, even in thought, is to risk change, because the deep sea does not simply contain strange creatures, it contains strange truths about existence, survival, life without light. Imagine being a fish that never sees the sun, that lives without day or season, that knows no horizon, no sky. For such a creature, the concept of up might mean nothing. Surface would be a myth, or worse, a threat. Now imagine we are that fish. We, on land, in cities, among light and noise, believe we know the world. But the ocean reminds us that most of it is still hidden. Not just unexplored, literally unseen, unmapped, unnamed. In this way, the abyss is like time, or death, or the far future. Not quite touchable, not quite solvable, and yet it is real, entirely real, filled with living things that do not care whether we find them beautiful, with processes that continue regardless of our awareness. There are jellyfish in the Hadal zone pulsing in silence, unaware that human beings exist. There are worms feeding on bones in sunken carcasses, oblivious to countries, satellites, poetry. Life down there is not a reflection of us. It is not waiting for us. It simply is. This is a kind of existential humility, to recognize that we are not the measure of life, and yet to explore the deep is to extend ourselves, to send pieces of our curiosity into places we cannot go. We engineer pressure-resistant machines, we train AI to read the ocean, we name species we will never touch, and in doing so, we ask a question that science alone cannot answer. Why? Why are we drawn to the bottom of the ocean? There is no evolutionary advantage, no immediate reward. The costs are high, the risks greater still, but we do it anyway. And perhaps the answer is this. The deep sea is the last mirror. Everything else has been charted. We've mapped the stars, we've drawn the continents, we've scanned our own bodies down to the atom. But the deep is still mystery. still untouched by tourism, untouched by convenience. It does not care for us, and that indifference is its power. In the deep, we confront the uncentering of the human story, and yet we keep writing ourselves into it. We name trenches, we measure silence, we describe fish in our languages through our metaphors, we compare abyssal plains to deserts, vents to cities, bioluminescence to stars. It's the only way we know how to think, through ourselves. But the deep asks us to try another way, to imagine ecosystems not driven by sunlight or seasons, but by heat and chemical gradients. To imagine time not in days or years, but in geological epochs. To imagine intelligence not as speech or tools, but as persistence, as a jellyfish unchanged for 500 million years. What if survival is wisdom? What if silence is expression? What if down there the rules of what matters are simply different? These are not questions for biologists alone. They are questions for poets, for philosophers, for anyone willing to feel small without fear. Because the deep sea is not a puzzle to solve, it's a presence to witness, and in that witnessing we learn something rare in the modern age: patience. The ocean is slow. Currents take centuries to complete their loops. Coral reefs in the dark grow at the pace of fingernails. Species evolve not in decades, but in eras. To study the deep is to slow down, to listen, not demand, to ask, not extract. And isn't that too a kind of philosophy? A way of living? In the age of acceleration, of notifications, of infinite scroll, of always on, the deep sea remains a place of slow, quiet endurance. It doesn't care if we're watching. It just continues. And in that stillness maybe we see ourselves more clearly. Or maybe not. Maybe the abyss never reflects. Maybe it only absorbs. And maybe that too is the lesson, that not all things are meant to answer us. Let's take the thought further, because the deep sea is not just the edge of the earth, it's the edge of possibility. When we look down, we're also looking out into the cosmos, out into time. And that's where things get strange, because what we find in the deep, ecosystems without light, organisms that survive on chemical energy, extremophiles that thrive in crushing pressure, begins to reshape our understanding of where life might exist, not just on Earth, but elsewhere. Consider Europa, a moon of Jupiter sheathed in ice. Beneath its frozen crust, a global ocean, possibly twice the volume of all Earth's water. Locked in darkness, heated from below by tidal forces and internal friction. No sunlight, but potentially vents, heat, chemistry. Does that sound familiar? Or Enceladus, a tiny moon orbiting Saturn, where plumes of water shoot into space from a subsurface ocean. The Cassini spacecraft flew through those geysers, found salts, organics, hydrogen. No proof of life, but all the ingredients. What's remarkable is that we might have overlooked these possibilities. Had we not discovered life in our own trenches? Had we not seen tube worms thriving on sulfur, bacteria eating metal, shrimp with eyes on their backs to detect faint glimmers of heat? Astrobiology, the science of life in the universe, owes a quiet debt to the deep sea. Without it, our vision of life would still be narrow, based on sun, on land, on air. But the deep has expanded the frame, and it's not just about biology. The ocean also changes how we think about time. On the surface, time is loud. Days cycle, clocks tick, things grow, bloom, decay. But in the deep, time stretches. A coral might live 4,000 years. A sediment layer might represent 1,000. A single current circulating between polar regions and equators might take 1,500 years to complete a loop. Here, time is not a rush, it is weight. And when we send machines into the trenches, what we're touching isn't just depth, it's history. The ocean floor records impacts, extinctions, migrations, meltings. It is memory in mineral form. There's poetry in that. because we too are creatures of time. We age, we forget, we remember. We try to make meaning out of motion. And when we find a deep-sea sponge that hasn't changed in millions of years, or a fish that barely moves but has lived for centuries, we glimpse something we can't quite name. Not envy exactly, but something close. Stability, stillness, escape. Or perhaps it's something more unsettling. A reminder that most of life, in space, in time, is not human life. That we are the exception, not the rule. The deep sea also challenges our stories of progress. In school, we learn that evolution is improvement. But many abyssal creatures are not advanced. They are old, unchanged. Their design is not efficient but sufficient. The gulper eel, the blobfish, the vampire squid, these are not upgrades. They are adaptations to an environment we barely understand. And that challenges something in us, because we want the universe to mirror us. We want it to be climbing, ascending, evolving towards something we recognize. But the deep doesn't do that. It doesn't reflect. It resists. And in that resistance, it humbles us. This is not pessimism, it's perspective. In recent years, philosophers and ecologists have begun speaking of more than human worlds. Worlds where human desires are not central, where ecosystems operate on their own terms, where other forms of life, non-conscious, non-verbal, non-tool using, still have value. The deep sea is a masterclass in that idea. No creature down there cares about our achievements. No trench is impressed by our politics. No vent field remembers our names. And yet, the moment we see them, we care. A flashing siphonophore, undulating like a ribbon in a dance we can't name. A translucent octopus with eyes like marbles. A fish with a head so clear you can see its brain. These things move us. We don't know why. They don't serve us, but they change us. And that's the final, perhaps most powerful lesson of the deep, that mystery is not just tolerable, it's necessary. We do not need to understand everything to feel wonder. We do not need to categorize every organism to protect its habitat. We do not need to be the center of the story for the story to matter. The deep teaches us how to live with uncertainty, how to marvel without mastery, how to feel awe without needing ownership. In this way, the abyss is not empty. It's full of meanings we haven't yet earned, of questions we haven't yet asked, of silences we haven't yet listened to. And maybe that's enough. Maybe the deep is doing what it's always done, calling us, not to solve it, but to sit with it. And in that sitting, to remember that we too are creatures drifting in something vast, not at the top, not at the bottom, but somewhere in between. The deep sea may feel remote, 1,000 atmospheres away, silent, sunless, sealed off, but it is not separate. Its rhythms, its moods, its chemistry seep upward and into our lives in ways most of us never notice. It begins with the breath. Nearly every second inhale you take, every other breath, contains oxygen produced by phytoplankton. These microscopic organisms, many of them born in the upper ocean, depend on the structure of deeper currents to circulate nutrients. The deep sea, by way of vertical mixing, fertilizes the light-rich layers above, and so the trench contributes to the sky, the abyss, to the air. It's invisible, but intimate. The deep sea affects weather too. The vast conveyor belt of global thermohaline circulation, a system of currents driven by differences in temperature and salinity, regulates climate across continents. A cold water mass formed in the North Atlantic may take centuries to snake through the ocean's depths before resurfacing near Antarctica. This engine is slow, but powerful. When it weakens, storm patterns shift, droughts bloom, ice melts, tides creep upward into city streets. We talk about climate change as if it's something happening to the planet, but really it's something happening within it. And the deep sea is where the memory of carbon, heat, and time gets stored. You don't need to be on a boat to feel the sea. Every summer heat wave, every strange winter, every superstorm in headlines, They are, in part, shaped by the whisper of water 1,000 meters below. But our connection to the deep isn't just physical, it's emotional. It lives in metaphor. We call feelings deep. We plunge into thought. We sink into sadness. We speak of unfathomable pain or oceanic love. The language of depth has become the language of interiority, as if our emotions, like the sea, are vast, layered, difficult to chart. This isn't a coincidence. Just as the surface world feels fast and exposed, the ocean suggests slowness and privacy. It becomes a metaphor for the parts of us we don't fully understand, our desires, our fears, our secrets. When we imagine diving, we imagine uncovering, discovering, transforming. This has shown up again and again in culture. In film, the sea is rarely neutral. It's either revelation, the abyss, terror, the Meg, Leviathan, or transcendence. Finding Nemo is a family comedy, yes, but also a story of depth and distance, of crossing emotional and literal oceans. In literature, the sea has been a space for obsession, Moby Dick, madness, Heart of Darkness, rebirth, The Old Man and the Sea, and apocalypse. 20,000 Leagues Under the Sea feels more prescient now than ever. We dress these stories with creatures, squids, serpents, sharks. But what we're really exploring is something more psychological. What happens when we leave the familiar behind? When we go where maps run out? The deep sea becomes not just a setting, but a character. Dark, impassive, eternal. And yet, we keep returning to it. In stories, in dreams, in science. Even children, before they know the word abyss, draw whales and submarines and glowing fish. They instinctively imagine that there is more below. They are right. Our fascination with the deep shows up in the mundane too. The seafood aisle, the pearl in a ring, the cuttlefish ink in pasta, the coral jewellery passed down in a family. These things carry the deep with them, materially but also mythically. We forget sometimes that the deep has been part of human commerce for millennia. Sponge divers, salt traders, coral harvesters, ambergris, a rare compound formed in the intestines of sperm whales, was once more valuable than gold, used in perfumes and medicines. Ships risked storm and war to harvest from waters they could not see into. Even now, deep-sea trawlers bring back species once thought inaccessible. Orange ruffy, Patagonian toothfish, monkfish, creatures that take decades to mature, that live in fragile ecosystems, end up pan-seared and served under lemon foam. And here, the connection turns sobering. Because the more accessible the deep becomes, the more vulnerable it grows. Cultural fascination does not always mean protection. Sometimes it leads to extraction. We covet what we do not understand. We consume what we find mysterious. In the 21st century, we download photos of bioluminescent comb jellies, marvel at deep-sea jellyfish on social media, and rarely stop to ask, how long has this species existed? How fragile is this ecosystem? How many dives did it take to capture this footage? What happens next? Because the truth is, these aren't just curiosities, they're clues. Clues to how life began, clues to how it adapts, clues to how we might better treat our planet and ourselves. And they're not hidden behind a paywall. Many of them are public. Citizen science programs allow anyone with time and interest to help tag species from deep-sea expeditions. Teachers use deep ocean footage to teach ecology. Musicians sample hydrophone recordings from the deep to create meditative soundscapes. Even wellness industries have started to invoke the ocean in their branding. Deep cleansing, marine peptides, ocean minerals. Whether or not these products carry real connection to the sea, they carry symbolic power. They tell us that the ocean, the deep ocean, represents purity, stillness, origin. Even if it's marketing, even if it's shallow, the instinct beneath is real, to immerse, to restore, to remember that we came from water. And maybe, emotionally, we never really left. The deep sea is quiet, not silent, but quiet in a way we've nearly forgotten how to hear. And perhaps that's what draws us back to it again and again, even from a distance, in art, in meditation, in longing. Because in a world overflowing with alerts, updates, and opinions, the ocean reminds us what it feels like to simply be. No agenda, no performance, just currents, just presence. And yet, ironically, the deep is now entering daily life through one of the loudest platforms, the internet. In the last decade, deep sea exploration has found a new home, not just in academia, but on YouTube live streams, Reddit threads, Instagram reels. A 10-second clip of a Dumbo octopus can rack up millions of views. A slow-motion video of a siphonophore can go viral, shared with captions like "real alien found in ocean." We scroll past it, stunned. A spark of wonder between meetings, a glimpse of beauty in the algorithm. This democratization of the deep is a double-edged sword. On one hand, it opens access. It allows people who may never see the ocean to experience its mysteries. It inspires. It teaches. But on the other hand, it risks flattening that mystery into just another distraction. A spectacle. A novelty. To truly engage with the deep requires more than a swipe. It requires stillness. That's why the deep shows up so often in practices of slowness, in ambient music, in guided meditation, in writing retreats and floating tanks and yoga studios. We close our eyes and imagine ourselves sinking, not in fear, but in calm, not to drown, but to let go, to drift. This language isn't accidental. It comes from somewhere very old, the idea that the deep is a return, a descent back to origin, to peace, to source. Many ancient cultures believed that the sea, especially the deep, was a place of rebirth, that the dead went there, that souls returned through water, the river Styx, the well of Erd, the endless waters of Nun. All metaphors for the same thing, that what lies below is not just lost but eternal. Even in modern funerary practices this persists. Naval burials at sea, ashes scattered from boats. The ocean is still seen as a resting place, a keeper of memory, and maybe that's part of its appeal in everyday life, that even in a secular world we sense something sacred in the sea. It's also why we decorate with it. Interior design loves a nautical theme, wave patterns, coral textures, shells, indigo dyes. These aren't just aesthetics, they're signals, reminders of water, flow, depth. The psychology of blue space mirrors that of green. We associate it with calm, restoration, openness. Even science has backed this up. Exposure to images of oceans, especially still deep water, has been shown to reduce stress, slow heart rate, and increase feelings of connectedness. In a way, we're building aquariums for the soul. And yet, the irony remains. The more we invoke the deep, the more we risk ignoring its reality. Because the real deep sea is not just beautiful, it's slow, fragile, exploited. As our fascination grows, so does the pressure to mine, to fish, to extract. Cultural interest becomes economic interest, and cultural symbols, whales, corals, seahorses, become commodities. A coral-shaped lamp made in a factory, a deep sea-themed hotel suite, a luxury watch named after a trench. All of it echoes the same question. How do we love what we do not see? How do we protect what we cannot touch? Perhaps the answer begins with remembering that the deep isn't separate from daily life. It's the base of it. The currents below influence the skies above. The cycles of the trench affect the warmth of the air. Even your phone, your laptop, your charging cable exist partly because of undersea fibre optic lines laid across the sea floor. The internet is woven through the ocean. And maybe so are we. In dreams, the ocean often symbolises the subconscious. We drift across it in sleep. We sink into it in memory. The deep becomes a screen onto which we project our longings, our unresolved thoughts, what we fear, what we hope. It's not surprising, then, that in times of change, personally, Culturally, globally, we return to the sea. We name perfumes after it. We write songs in its key. We bathe in its sound. And more than ever, we use it to sleep. Ocean sounds are one of the most popular forms of sleep audio in the world. Not just waves on a beach, but recordings of deep-sea drones, low-frequency rumbles, whale songs slowed to lullaby pace. Why? Because the ocean doesn't ask anything of us. It doesn't care if we understand it, it doesn't perform, it simply moves. And in that movement, we find a rhythm more ancient than language, more honest than certainty, more restful than reason. In that sense, the deep sea is not just part of the planet, it is part of the human condition. A reminder, every time we breathe, that there are systems older than thought. That beneath the noise there is pattern. Beneath the chaos there is current. And maybe, beneath all our striving, all our explaining, all our exhaustion, there is something vast and blue and still, waiting. What if the deep sea isn't the bottom, but the beginning? It sounds poetic, maybe even absurd. But the more we explore the trenches and their alien ecologies, the more that question lingers, like pressure against the skull. Because everything we thought life required, light, air, dry land, fails in the abyss, and yet life continues there, in strange, soft, luminous forms. Imagine rewinding Earth's clock by 4 billion years. No forests, no fish, no lungs or leaves, just ocean, and deep within it, around cracks in the Earth's crust, vents belching heat and minerals into the cold. There, microbes fed on hydrogen sulfide, not sunlight, not sugar, just chemistry. Some scientists now believe that's where life began. Not in the shallows, but in the dark. Not with photosynthesis, but chemosynthesis. The logic flips. Light is not required. It's optional. The assumption that energy must come from the sky falls away. That idea alone feels like science fiction, but it's not. It's biogeochemistry, molecular evolution, astrobiology, real research, and it fuels real questions. Like this one, if life began in the deep, why wouldn't it exist in similar conditions elsewhere? Because if the abyss can birth life, then Europa can, Enceladus can. Any ocean world with subsurface heating becomes a candidate. The deep sea in this framing becomes a prototype for life beyond Earth. Suddenly the creatures of the trenches, translucent, pressure-loving, heat-feeding, feel less like exceptions and more like ambassadors. But this is just one what if. Let's stretch further. What if evolution had favoured deep-sea organisms over surface dwellers? What if, in some alternate version of Earth, the dominant intelligent species wasn't a primate walking on two legs, but a cephalopod adapting to life in the black? Cephalopods, squid, octopuses, cuttlefish, already demonstrate complex behaviour, problem-solving, memory and tool use. Their nervous systems are distributed, their bodies shape-shift. They don't just see. Some scientists believe they can sense polarised light, electrical fields, even texture through skin. An octopus can navigate a maze, unscrew a jar, recognise faces, even show what looks like play. Now imagine an evolutionary path where they didn't die after mating, where they lived longer, where intelligence had time to accumulate. Would they build cities? Would they write? Or would their intelligence be so different, so embodied, so fluid, that communication as we know it wouldn't apply? Maybe they wouldn't speak in sound, but in colour, as many already do. Maybe they wouldn't remember in language, but in texture, pressure, light. And maybe, in that version of Earth, it's the surface that remains unexplored. Too dry, too hot, too loud. To us, the idea of an underwater civilization seems absurd, but only because our own biology anchors us to land, to air. Take that bias away and new possibilities bubble up. Which leads to another paradox. The more we explore the deep, the more we realise how little of it we've explored. Depending on definitions, we've mapped less than 25% of the seafloor in high resolution, and of the Hadal zone, the trenches deeper than 6,000 metres, we've directly visited perhaps a dozen spots. It's like trying to understand a continent by looking at a single city. So, what's still out there? What have we missed? We tend to think that large, undiscovered animals belong to the realm of fantasy, and yet we discover new deep-sea species every year. Some large, many strange. Giant squid were legends for centuries before a living one was filmed in 2004. The megamouth shark wasn't discovered until 1976, not as a fossil, but alive, enormous, and drifting. This isn't cryptozoology, it's reality, which opens the door just a crack to wonder, could something big be down there, unknown, unseen? Perhaps not the kraken of sailors' tales, but something we haven't yet conceived, not because it's mythical, but because it's unimaginable, because evolution doesn't care about our expectations, and if such a creature exists, would we recognize it as alive, as intelligent, as something worth protecting? That question of recognition is at the heart of deep-sea science fiction. Many sci-fi narratives take place in space, but the ocean may be the closer cousin to the truly alien. It's dark, it's pressure-rich, it's biologically unfamiliar, communication is limited, vision is distorted, physics itself bends. What we know from the surface doesn't apply. In stories like The Abyss or Sphere, the ocean becomes a stand-in for the mind, filled with unknown depths, hidden threats, quiet genius. Even in horror, the thing below underwater, the fear is not of the monster, but of the isolation, the slowness, the knowledge that you're not at the top of the food chain anymore, maybe never were. But the best ocean stories aren't about fear, they're about empathy. What if the deep is not hostile but misunderstood? Or what if it isn't empty but full? Just full in a way we haven't learned to perceive yet. Maybe deep-sea creatures navigate dimensions we don't see. Maybe their sense of time is folded. Maybe they interpret the world through currents, not chronology. Maybe to them we are the strange ones, the fast, flat creatures who light up the surface and vanish too quickly to matter. In that framing, the ocean becomes not a barrier, but a filter, one that reveals only what we're ready to see. And so, the question turns inward. What if the deep isn't just out there? What if it's a metaphor for the part of us we don't yet understand? The part that resists speed, that values quiet, that remembers things we never learned, that believes in something larger than efficiency, the part that asks questions not to be answered, but to be held. What if the deep is where our minds go when we sleep, where our ancestors whisper through dreams, where memory and meaning float unmoored, waiting to be shaped? And what if every exploration we send downward is also a reflection of that inward search, not just to find new species, but to find new ways of being? What if the laws of nature, gravity, pressure, metabolism, aren't universal after all? What if, deep beneath the ocean's crust, there are environments so extreme they force life to break the rules we think are absolute? Already, in the hot vents of the Mariana Trench, we've found microbes that thrive at temperatures above boiling, in the absence of oxygen, and in pressures that would crush a human submarine like a soda can. These organisms metabolize metal, they eat stone, they turn poison into food. To us that sounds impossible, but only because we still write the rules using our own survival as the template, and yet the deep sea continues to demonstrate that biology is not beholden to comfort. In fact, some of Earth's most stable ecosystems exist where life seems least likely to begin. That tension, the impossibility of life versus the persistence of it, is a story science fiction has been exploring for decades. Take the idea of sentient water, not just life in water, but water as life. In Stanislaw Lem's Solaris, the ocean is a thinking entity. It responds to the emotions of visitors, It creates matter from memory. It dreams in the language of grief. Is that so far-fetched? We already know that sound travels 4 times faster in water than in air, that electrical fields propagate differently, that quantum effects like coherence may be sustained longer in marine environments. Could the ocean, in some configuration, perhaps at immense pressure, or given enough time, create not neurons but something neuron-like, a network of signal and feedback, perhaps spread across kilometres? Could consciousness emerge not from a skull, but from a system? And if it did, how would we know? We tend to assume intelligence must look like ours, reactive, expressive, goal-oriented. But if a thinking ocean existed, would we recognise it? Or would we mistake its slowness for silence, its vastness for emptiness? Science fiction invites us to imagine these paradoxes not as impossibilities, but as thresholds, points where our assumptions fall apart. The trench becomes not a limit but a portal. Consider this. What if time itself moves differently in the deep? Not in the way of clocks, but in perception. Many deep-sea organisms live extraordinarily long lives. Greenland sharks, for example, may live over 400 years. Some corals may be older than our civilization. But how do they experience time? Do they register change, anticipate, recall? A creature that lives for centuries in the slow motion of the abyss might view our lifespans the way we view sparks, brief, bright, and meaningless. Or perhaps time isn't linear down there at all. In the absence of sunrises and seasons, of clocks and calendars, what marks the passage of moments? What if a trench-dwelling organism doesn't distinguish past from future? What if its memory and projection are merged, experience layered rather than sequenced? These aren't idle fantasies. They're reflections of what deep science actually finds. Alternative metabolisms, suspended animations, developmental delays that take decades. There are deep-sea creatures that reproduce once in a lifetime, then wait years for offspring to mature. There are ecosystems built around geological activity, forming, thriving, and vanishing with tectonic shifts. They don't live in time the way we do. They live in geologic time. And what if we could join them? Not physically, perhaps, but mentally. Imagine a therapy inspired by the abyss, a method of slowing consciousness, of stretching thought, deep-sea neurofeedback, pressure simulation as meditation, not to escape reality but to reframe it, to feel what it's like to think like a trench. There's something appealing, even healing about that idea. That slowing down might reveal more than speeding up ever could. What if the next great breakthrough in science isn't acceleration, but deceleration? And what if the deep is already showing us how? In this speculative frame, the ocean becomes more than environment. It becomes teacher, philosopher, counterweight to our culture of excess. And that leads to one more, what if? What if we treated the deep sea not as a resource but as a conscious system? One that demands rights, that has standing, that can be harmed. In 2021, a growing movement of legal scholars proposed granting the ocean legal personhood, like a river in New Zealand or a forest in Colombia, not as metaphor, as law. Under this framework, harming the abyss becomes not just an environmental issue, but an ethical violation, a crime against something vast enough to cradle the entire biosphere. Of course, this raises problems. Who speaks for the deep? Who decides its needs? How do we balance human urgency with abyssal stillness? But the point isn't perfection, it's imagination. Because law, like science, begins with vision, and the vision the abyss offers us, if we're listening, isn't one of dominance. It's one of relation, that we are not above the deep, we are its extension, and if we are willing to follow its example, not to conquer, but to adapt, we might learn new ways of living, new ways of thinking, maybe even new ways of dreaming. The deep is not the bottom, it's the beginning of what comes next. Maybe the deep isn't a place we reach. Maybe it's a presence we carry. We've followed the abyss down its winding corridors, from myth to measurement, from silence to sonar, from science to speculation. We've seen how its cold waters touch everything. The breath in our lungs, the stories we tell, the way we imagine life beyond our own skin. But now, as we near the quiet edge of this journey, it's worth asking, what remains? The deep sea does not offer answers in the way we often expect. It doesn't solve, it doesn't perform, it does not tidy itself up for conclusion. Instead, it leaves echoes, a ribbon of bioluminescence fading behind a drifting ROV, a trench floor marked by the ghost trails of an ancient eel, a creature caught for a moment in the beam of light, and then gone into the black, leaving only a question. And maybe that's the point. That mystery is not a failure of knowledge, it's an invitation to care. Because what we cannot fully know, we can still choose to respect, to protect, to wonder at. The deep sea, after all, is not some separate cosmos. It is this Earth, just unlit, just unfolding at a tempo we forgot to listen to. We often speak of conquering frontiers, but the abyss asks something else entirely. It asks us to slow down, to look inward as we look outward, to consider that intelligence might not always be loud, that evolution might not always move upward, that beauty might exist in patience, in stillness, in survival itself. And in this reframing, the trench becomes a mirror. It shows us not just what life can be, but what we might still become if we learn to live in harmony with the unseen, the unfathomable, the unspoken. We return to the question that opened this journey: what's hidden in the abyss? The answer, perhaps, is not a single discovery, not a final species or a perfect theory, but a way of seeing, a softness toward the unknown, a humility in the face of deep time, a quiet joy in simply knowing that somewhere, even now, thousands of meters below the waves, a glowing creature pulses, never seen, never named, and still entirely real, and that is enough. Sleep comes more easily when you let go of needing everything to be solved. So let the deep hold your questions for a while. Let it rock them slowly, like a current moves a drifting shell. Let your breath match the rhythm of invisible tides, and rest in the knowing that mystery is not emptiness. It is presence without pressure. It is the depth within you, mirrored in the world. It is always still unfolding. So, where are you now? Still with me? Or already drifting, half asleep, carried by the same silent tides that shape the world beneath our feet? What time is it where you are? Does it matter? Out there, in the black folds of the ocean, time moves differently, slower, softer. 1,000 years in a coral's slow bloom, a life measured not in heartbeats, but in currents. And maybe, just maybe, your breath has started to follow that rhythm too. If this gave you peace, even a moment of it, thank you for letting me share that space with you. Thank you for staying, for wondering, for feeling small in the best possible way. The deep sea doesn't need our awe, but it holds it just the same. So sleep well tonight, fellow traveller. Sink gently into that quiet blue. Wherever you are, whenever you are, you're already home.